Backpack sprayers are an essential part of many agricultural enterprises. The ease and convenience they offer, whether broadcasting in a field or pinpointing a specific crop or shrub, is undeniable for many growers. The key to effective spraying of any kind is the efficiency of a properly calibrated and prepared sprayer unit. Consequently, a poorly calibrated or equipped unit can prove unsafe and very costly. Let's take a few minutes and review the steps for proper setup and calibration. The first step is about safety. Always consult pesticide and manufacturer's labels for requirements on PPE or personal protective equipment. Depending on products used in the sprayer in the past, it may be necessary to wear gloves, safety glasses, or boots when performing a calibration. When preparing to spray product on a field or crop, you may also need to wear an apron to avoid splashing during tank mixing. For the purposes of this video, the demonstration sprayers have only ever been used with water, and as such do not require PPE during this program. Next, let's consider the three main variables related to backpack sprayers. They are pressure, nozzle size or type, and applicator speed. Most hand pump sprayers vary in the amount of pump action required to produce a steady output of material. Some sprayer wands come with, or can be equipped with, a pressure gauge to measure and observe output. Another solution may be the addition of a dual compensating control flow valve. These valves are designed to prevent low pressure output and will restrict higher pressure to a limited level, creating a steady, consistent pressure during application. Nozzle sizes and types come in different varieties and for multiple purposes. Make sure that the size and type nozzle called for on the pesticide label is the one being used during the calibration process in order to maintain that consistency during spraying. If the nozzle attached has been previously used, make sure that it is properly cleaned and unclogged in order to allow correct product flow. When cleaning the nozzle, use compressed or canned air rather than blowing through the nozzle to reduce unnecessary pesticide exposure risk. If the nozzle needs further cleaning, use recommended brushes and cleaners. Just simply poking a wire through the nozzle could result in damage that permits too much product flow, wasting chemicals and perhaps damaging crops or inflating pesticide costs. Applicator speed can be the most challenging variable, as it is only corrected by the applicator themselves. The most effective tool for an applicator is to determine a consistent pace by keeping in mind a cadence, perhaps one for slower, more consistent speed, and one for an up-tempo pace as the product or application may require. This takes some self-discipline and a good bit of practice, but knowing how to control your pace with some degree of accuracy will help to create the consistent and effective control of spraying that leads to efficiency. The next step in the process is knowing the proper methods for spraying. Many backpack injuries occur when an applicator bends over to lift and slip on a backpack. Using a table or a tailgate can make putting on your backpack easier and safer. Simply back up to the unit and slip into the straps. No heavy or awkward lifting necessary. You can also use the legs of the table to help measure nozzle height. Most manufacturers' labels will suggest a 20-inch or a 30-inch height from the target to the nozzle tip. By marking the table legs with a piece of ribbon or tape at the appropriate height, the applicator can see where the wand needs to be held for proper spraying. While it may seem to make sense to move the wand in a back and forth pattern while walking, a closer examination will show that this creates a Z pattern, indicating an uneven application. Whether pacing slowly or quickly, a steady, consistent spray directly in front of or beside the applicator will provide the best coverage in a broadcast setting. The back and forth or up and down pattern will work best with a controlled pace when applying product in a more vertical setting, such as shrubs. Now that we know the most effective methods for using the backpack sprayer, let's look at the calibration process using the 1/128th method. This method offers a very basic and easy to calculate way of measuring gallons per acre usage in an agricultural setting. First, mark out a plot of ground measuring 18.5 feet by 18.5 feet square. This plot measures out to 1/128th of an acre. Using a stopwatch, measure the time it takes to make an application of the square. While the applicator is walking the area, be sure to stop and start the stopwatch according to the stop and start action of the wand being used. For this demonstration, the time measured was 41 seconds. Next, for that same amount of time, 41 seconds, Use the wand to dispense liquid from the backpack into a measuring cup designed for pesticide use, using the same pressure and consistency used during the spray. For this demonstration, the amount of collected product was 22 ounces. Because we know that there are 128 ounces to a gallon, and our plot size was 1/128th of an acre, we can determine that the amount of product applied translates from ounces to gallons. In other words, at the rate measured during the timed application, that same rate would apply 22 gallons per acre. Ideally, you'll want to repeat this process a total of at least 3 times in order to determine an average and more accurate measurement. When determining a calibration for an area, such as a shrub or bushy area, employ the same tactics of a steady, timed, and thorough coverage. Once completed, collect spray in a measuring cup for the same measured time. In this demonstration, for 38 seconds, we collected 21 ounces. Use the best information available to determine the square footage of the shrubs, in this case 250 square feet. Then calculate the multiplier to reach a total of 43,560, the amount of square footage in an acre. For this demonstration, that number is 174.24. Multiply the 21 ounces for a total of 3,659 ounces, which divided by 128 gives us roughly 28.5 gallons per acre. Again, multiple tests for creating an average is the best way to go. As we mentioned previously, properly calibrated sprayer equipment is essential to achieving efficient and cost-effective pesticide applications. And in so doing, you can be assured of better crop yields and a tighter control over chemical costs for a superior bottom line. Thanks for watching. For further information about this or other calibration information, head to the website on your screen.